All right, this is on rational exponents. So rational means fractional. So we have some examples of what a radical will look like and what it will look like as a rational exponent. So what I'd like you to look at is the very bottom of this slide where it says 7 raised to the 1/2 power is the same thing as the square root of 7. All right, here is the definition of a rational exponent. It can be rewritten as n square root of a. And then if you have a negative fractional exponent, it can be written as a fraction in the denominator or as such. So we'll show you an example here. All right, so 125 raised to the 1/3 power. So that 1/3 power written as a radical is going to be the cube root of 125. Then you want to reduce that cube root of 125. So you're looking for perfect cubes. So 125 can be written as 5 times 5 times 5, or 5 cubed. So the cube root of 5 cubed. And then notice the index and the power are the same, so they undo each other. So your final answer then is 5. All right, example C, negative 16 raised to the 1/4 power. What I suggest that you do is you're going to ignore that negative for now and just change that to a radical. And then 4th root. It's a little bit lagging there, and then a negative out in front. All right, so now I'm going to take the 4th root of 16. So looking for perfect 4th powers. So 2 times 2 times 2 times 2, or 2 to the 4th. All right, and so now negative will be out in front. And then 4th root of 2 to the 4th is 2. All right, next example, E, 64 raised to the negative 1/3 power. Negative exponents. This is what we're looking here in the red. When you have a negative exponent, it's going to change it to a fraction and then change that to a positive. So it's going to be 1 over 64 raised to the 1/3 power. Makes it positive. Now you're ready to tackle that denominator. You're going to change that denominator to a radical. That's going to be a cube root of 64. Now you're going to simplify the cube root of 64. So you're looking for perfect cubes. So 4 times 4 times 4 is 64. So the cube root of 4 cubed, your index and your power match up, so they cancel each other out. So that denominator is going to be a 4. So your final answer is 1/4. All right, definition of a to the m divided by n. You can rewrite this as a radical, and you can put that m, the numerator, either outside the radical or underneath the radical. It depends sometimes on just what type of radical you have, radicand. Also notice here if you have a negative power, it's going to flip down to the denominator. So here's our first example. 27 raised to the 2/3 power. So to write it as a radical, 27 squared, and then your index is 3. Now that 2 can be underneath or it can be outside, and I'm going to make it outside, and you'll see what's going to happen here in a minute. Okay, so that 27, and then it's going to be a squared. So we're going to work in the innermost parentheses first. We're going to take care of this. Can we reduce that cubed root of 27? Yes. The cubed root of 27 is 3 because 27 is a perfect cubed. So what it looks like is 3 as your index, so cube root. 27 is 3 cubed. And that 2 is still outside. So index and power match up. So they're going to undo each other. So you're going to be just left with 3. And then squared. Now you're able to simplify that squared as 3 times 3, or 9. All right, simplifying using the properties of exponents. So you have 2 exponential terms, and you want to simplify them. So we're going to go ahead and multiply like pieces. So we're going to take the coefficients first, 5 and 7. So 5 times 7 is 35. And then we're going to multiply x to the 1/2 times x to the 3/4. Now, properties of exponents say if you have common basis, you have an x and an x, and you're multiplying them. The rule is you add the exponents. So we're going to be adding this 1/2 and this 3/4 together. So 1/2 plus 3/4. Well, these fractions are not alike, so we have to change them to be like denominators. So the least common denominator is going to be 4. So we're going to change that 1/2 to 2/4. Now 2/4 plus 3/4 is 5/4. All right, and we have that x. Now what we have is a single term rational exponent. We can now change that to a radical. The 35 will stay outside, and then the x raised to the 5/4 becomes the radical piece. And then you can continue breaking that down as 4th root of x to the 4th, and then 4th root of x, because you're looking for powers to the 4th. I don't want to do that, sorry. I need to extend the page here. All right, so this piece here, 4th root of x to the 4th, just becomes x. And then what's left is the 4th root of x. Here's another one, simplifying using the properties of exponents. So when you have an exponential divided by another exponential, and they are the same base, you can subtract those exponents. So before I do that, I'm going to go ahead and reduce 32 and 16 by a common factor. 32 and 16 can reduce by 16. This will become a 2 and then a 1. Now we're going to go ahead and divide these common bases. So the rule is we can subtract those powers. So 2 divided by 1 is 2, and then subtract those powers, so 5/3 minus 3/4. Now 5/3 and 3/4 are unlike, so we need to change their denominators to be alike. So the LCD is going to be 12. So in that first fraction, we need to multiply the numerator and denominator by 4. So 5 times 4 is 20. 3 times 4 is 12. And then the second fraction, we need to multiply the numerator and denominator by 3. So we're going to get 9/12. Now we're ready to go ahead and subtract those fractions. So 20/12 minus 9/12 is 11/12. All right, I'll stop there.